Alright, our quick little lesson today is on two very important things that don't take a long time to understand. So I hope to keep this to 10 minutes, but I'm sure it'll end up spilling into 15. So what we're going to talk about is this average value formula, and then on the back we're going to talk about rules for integrals. So first I'm going to start with the average value formula. The average value formula is really a formula involving an integral that says if you want the average value of a function on an interval from a to b, first that function has to be integrable, which means it can't have a lot of breaks or jumps in it. As long as it's continuous, we should be okay. But we will talk about integrable a little bit later. But basically, if I want the average value of a formula, average value, pardon me, of a function, the formula is 1 over b minus a, the integral from a to b of f of x dx. And really what we're doing is we're just taking the integral of the function across a certain interval and then dividing by the width of the interval. Okay? And it's not a big formula to memorize, but you do have to memorize it. And the way I always think of it is it's really like the way you normally calculate an average, okay? You take the sum of the function. Remember, this integral sign is really a summation sign. You take the sum of the values of the function and then divide by the width of the interval. So you're kind of like adding up a whole bunch of stuff and then dividing by the number of things that are there. So if I wanted to find the average value of, let's say, y equals x squared on the interval from 0 to 3, what we're going to do is say, all right, set up a definite integral to find the average value. So using the formula, I should have 1 over b minus a, the integral from a to b of f of x dx. And in this case, that's 1 over 3 minus 0, the integral from 0 to 3 of x squared dx. So this is the definite integral that means find the average value of x squared from 0 to 3. Now the new thing we're going to do here is now we're going to use our calculator to evaluate that integral. So what I'm going to do to get that is I'm going to bring up my calculator, and you're going to do this too. And I'm going to do this two different ways depending on what type of calculator you have. So kind of bear with me. If we get to a part where you don't have your calculator on the screen, just feel free to speed me up or fast forward a little bit. So if you have in your mode, if you have something that says next here, or you have one of the new fancy ones where it looks even bit different than this, but if you go to next and then you go and you see something that says math print versus classic, I'm going to be doing this first example in math print mode, okay? So I'm going to quit out of here. And then I need to find, well, how do I do this? Well, 1 over 3 minus 0 is just the same as 1/3. So I need 1/3 times an integral. Well, the integral is in the math button, and it's down here at math 9, FN int. So if you hit math 9, you'll get this awesome looking integral. And really, then you just plug in all the stuff that you need. So I need the integral from 0 to 2. Nope, 3. Sorry. Come back. There we go. 0 to 3 of x squared dx. And now it looks like exactly what's on our paper. I can just hit enter, and da-da-da-da, I find that the answer is, in fact, 3. Okay? Now, if you do not have the math print on your calculator, what you're going to do is I'm going to come back to mode. I'm going to turn off math print, and classic mode is what you will have if you don't have math print. The process is still the same. I still want to do 1/3 times the integral. Well, to get to the integral, you still do math 9, okay? Except now, instead of having the pretty integral, it says fn int. This has a syntax, and the syntax for fn int is integrand, so x squared, comma x, so we're taking the integral of x squared dx, comma, from 0 to 3. So the syntax for fn int, if you have these parentheses here, are x squared, comma x, so function, comma x, comma, lower limit of integration, comma, upper limit of integration. And then I hit enter, and I still get 3. Okay? So if you have the nice pretty math print, it's nice because you know exactly if you're doing what you mean to do because it looks like it on paper. Fn int, it's function, comma, x, comma, lower bound, comma, upper bound. Okay, so I'm going to quickly go back to math print here just for our purposes later on so it looks nicer. If you have questions about your calculator, just come and see me. All right. So now we're going to graph the function and then graph that value as a number. So if I graph y equals x squared, 0, 0, 1, 1, 2, 4, 3, 4, 5, 6, 7, 8, 9, 3, 9 is up here. Here's y equals x squared. Wow, that's terrible. There's y equals x squared kind of from 0 to 3. So if I look at this and I think about, well, what's its average value? Well, it goes from 0 to 9, right? But it goes from 0 to 9 on a width from 0 to 3. And 9 divided by 3 is 3. That's not really how it works, but in this case, it actually does kind of work that way. Um, here's y equals 3. So does the function ever equal the average value? Well, yeah, it does. The function absolutely equals 3 on that interval. And, well, it equals 3 whenever x squared equals 3, which is that x equals the square root of 3. Now, this part's really not necessary. We're just doing it because it told you to. But really what's happening here is I just want you to see that when I have a function, that the function itself should equal its average value at some point. All right. So, going a little faster here, find the average value of 3 to the x on the interval from 1 to 2. Show the integral. So, the average value, again, is really a formula. 1 over b minus a, so 1 over 2 minus 1. The integral from 1 to 2 of 3 to the x dx, which is just really 1 times the integral from 1 to 2 of 3 to the x dx. So take out your calculator, do the math 9 thing. So I need the integral from 1, nope, I didn't mean to hit 0, from 1 to 2 of 3 to the x dx. Nope. Sorry, my calculator is extremely slow sometimes and it doesn't do what I want it to do. There we go. Hit enter. And the average value of 3 to the x dx is 5.4, what was that? Give me your calculator, where are you? 5.461. Remember 3 decimal places. And there you go. There's the average value of 3 to the x. Then the other thing we can do with average value is we can estimate it. Because average value is meant to be done on an integral, we've been doing all these things to evaluate integrals by estimating, as in Riemann sums and trapezoids. So if it said estimate the average speed of a car traveling along a road on 0 to 14, use the intervals given and the trapezoidal rule, here's what we're really doing. If I want to find the average value of a function, yeah, I don't know what the function is, I can estimate it using Riemann sums or trapezoids. All right, so if I want the average value of velocity, or in this case speed, because velocity is always positive, if I want the average speed on a certain interval, I really need 1 over 14 minus 0, the integral from 0 to 14 of v of t dt. I need to evaluate this integral. Well, I can't because I don't know a function for velocity. So this has approximately a value of 1/14th the area under the curve as found by using trapezoids. So the 1/14th stays, and to evaluate the integral, we're going to estimate it using trapezoids and the numbers found here. So remember, trapezoids are the width of each interval over 2, h over 2, b1 plus b2. And then let's see, the width from here to here over 2, so my width is 3 divided by 2 times 65 plus 69 plus another width, 3 over 2, 69 plus 74 plus 8 to 14 is 6, 74 plus 85 And we're going to add all this stuff up and divide by 14. And if you can just trust me on this to speed us along, that's going to be 72.321. So the average speed is 72.321 feet per second. Okay, and you might think, wait, I got 55, 65, 69, and then 74 and 85. 72 doesn't seem right. I got a lot more 50s and 60s. However, you got to pay attention to what's going on. We're in the 50s and 60s from 0 to 5, and maybe a little bit beyond 5. So let's say it changes over to 72 at 6. From 6 to 14, it's at 72 and above. And from 0 to 5, it's at 72 and below. So it's at 72 for plenty of time. Don't worry about that. Okay? All right, so basically, long story short on this page, I just need you to know the average value formula. When you're asked to find the average value of something, it's 1 over b minus a, the integral from a to b of f of x dx. What does this mean for the AP exam? It means know this. It will come up 2, possibly 3 times on the exam because it's a pretty big deal. We need averages a lot, so they test you on it a lot. All right, how am I doing on time here? I try to keep these short. Yeah, I'm already at 11 minutes, so. All right, moving to the back. This is going to go fast, I promise you. These are rules for integration. So if you have an integral, how do you evaluate it? How do you use some tricks to maybe make it faster or more efficient? So one of the rules is an order of integration rule. So if you have the integral from b to a of f of x dx, but you want to make it the integral from a to b of f of x dx, you just put a negative in front of it. In other words, if you swap the bounds, you negate the integral. Okay? So, integral from b to a, integral from a to b, you get the same number, but one's just negated. All right, 0. If you integrate from a to a of f of x dx, that means like find the area from 2 to 2. Well, there is no area beneath a graph, any graph from 2 to 2, so you get 0. So if the bounds are equal, then the integral equals 0. Okay? Constant multiple rule. Integral from a to b of k times f of x dx, you can pull the k out front. Well, if k is negative 1, that means if you have the integral of negative f of x dx, you can pull the negative out in front. So in other words, if you have a coefficient, coefficients jump out front. It's basically kind of like taking out a GCF just to make everything easier. Now, that GCF has to be a constant. It can't be like an X or anything like that. But if you have a coefficient that's a number, absolutely bring it out in front. I'm going to do it all the time. You'll get used to it. The sum and difference rule. If you have the integral from a to b of f plus g, you can make it the integral from a to b of f plus the integral from a to b of g. Totally okay. All right, so AKA add inside equals add separately. Okay, so if you're adding inside the integral, that means you can add the integral separately. Same thing goes for subtracting. Okay, and then last but not least, this guy down here called the additivity rule says the integral from a to b of f plus the integral from b to c of f equals the integral from a to c of f. Well, let's think about what that means. If I take the area underneath the curve from 0 to 2 and then add it to the area underneath the curve from 2 to 3, isn't that going to give me the area from 0 to 3? Well, yeah. I'm saying area, I really mean, remember what we talked about, net area. But if I have the net area from 2 to 3 and then the net area from 3 to 4, it's like going from 2 to 4 in the first place. So in other words, I always kind of call this is the AKA is that 2 parts make a whole. Okay. Now, what you really need to make sure you know here is there is no multiplication or division rule. If you have the integral of f times g, it's not 2 separate integrals multiplied. Or if you have the integral of f divided by g, you cannot pull those apart. If you have multiplication or division within an interval, you absolutely cannot separate them. Okay, there are long involved processes that deal with multiplication and division that we're going to get into later, but you absolutely cannot separate them. You can do it with addition and subtraction, that's fine. You cannot do it with multiplication or division. It is not allowed. It's the same reason that when you're multiplying derivatives, there is a product rule. When it comes to integrals, there actually is no product or quotient rule. There's lots of rules that you have to try and try again until you find one that works. We'll get into that. All right, so down here, I know it looks like a lot, but this is actually quite fast. If you're given these things and I ask you to evaluate the following, all I'm asking you to do is use the rules above to try to evaluate these. So I'm going to go through 2 of these and then have you try the rest and just come back and check your answers because we'll speed these up a little bit. So integral from 3 to 7 of g is 2, integral from 0 to 3 of g is 5, 0 to 7 for h is 4, 3 to 7 for h is 3. Okay, we're going to use all these things to evaluate the stuff down here. So let's say A, integral from 0 to 7 of g. Well, I have 3 to 7, and I have 0 to 3. So 0 to 3 plus 3 to 7 for g would be 5 plus 2, which is 7. That's the additivity rule. 2 parts make a whole. Integral from 7 to 3 of g. Well, I have the integral from 3 to 7. Therefore, the integral from 7 to 3 is just the negation of this guy. Swap the bounds, negate the interval. All right, I want you to take a second and I want you to pause real quick, answer these, and then come back, and we will go over them together in 1 second. All right, so welcome back. I'm going to do this as quickly as I can here. Part B, integral from 7 to 7 of m. No, that wasn't a typo. I was just trying to show you. It doesn't matter what's here. 7 to 7, going to be 0. See, we did together. D, 5 times g from 0 to 7. Pull the 5 out front. Is 5 times the integral. So 5 times 7, 35. E, the integral from 0 to 3 of h. Well, I had 0 to 7 and 7 to 3. So you take the difference of those two to get the 0 to 3. 1. Integral from 3 to 7 of g plus h, you just add 3 to 7 for g, 3 to 7 for h, 2 plus 3 is 5. g of x plus 2 means it shifts up 2. We've talked about this before. So if it shifts up 2, I have a rectangle with a height of 2 and a width with the same width as the interval. So 2 times 4 is 8, plus the value of g of x from 3 to 7, which is 2. 2 plus 8 is 10. g of x plus 2 means I'm shifting the function to the left 2, and as long as I shift the bounds to the left 2, this integral has the same value, as the original integral from 3 to 7, and that was 2. And then last but not least, these two unique guys down here. The integral of 2 times g minus 3 times h is just 2 times g minus 3 times h, which is 2 times 7 minus 3 times 4, which is 14 minus 12, which is 2. This one's a little trickier. 0 to 14 of h from 2 to x. What this really does, 2 to x, h of x divided by 2. h of x divided by 2 widens h by a factor of 2. So what happens is all the y values stay the same, but we widen the base by a factor of 2, which means when I do base times height, I've actually doubled the base amount, but the height amount has stayed the same. So what happens is you stretch it out by a factor of 2, which just multiplies that net area by 2. So the net area from 0 to 7 for h was 8. Was 4, The area from 0 to 7 was 4, but now I'm taking this area from 0 to 14 because I've stretched it, so that duplicates it by 2. And we can talk about that in class a little bit more, and I can kind of show you what's going on there. But basically, this is 2 times 4, which is going to be 8. All right, so this was longer than I said it was going to be. I knew that that was going to happen, but hey, we got through it. I hope you guys had a wonderful day, and you're enjoying this, and I'll see you soon. Bye.